Okay, so hi everybody. Common question that I'm getting here is about plotting for the B activity. So I got my functions right here, and I got my graph right here, and so we're going to plot the positions of this, and then I'll go over some other extra questions that people seem to be having. So what I'm asking you to graph is actually a vertical position graph versus a horizontal position graph. This is similar to what we've done with our projectiles as well, is that it's a vertical position versus horizontal position graph where time is a parameter in that position. So, for example, we've had like the vertical position is equal to the, so the vertical position as a function of time is equal to the initial vertical position plus the initial vertical velocity times the time plus 1/2 times the acceleration in the vertical direction times the time squared. So that's the vertical component of the equation for a projectile. And then the horizontal component would be the same thing, except the acceleration 0, so I'm not going to write it. And these two equations can be plotted. So depending on what these depending on the time, right? Depending on the time, the object is at different positions, and it'll have different velocities, et cetera, et cetera, et cetera. So that's a time as a parameter in these equations. So where you're graphing vertical position versus horizontal position, but then time is the parameter, meaning depending on the time, it's at different positions. Okay. So that's what I'm going to do here. I'll show you kind of how to plot this. The first one I'm going to do, and again, you can use Google Sheets here, but I'm just going to show you by hand. So if I plug in, if I plug in Rx of 0 and Ry of 0, I'll get, so plugging in 0 for time, I'm going to get cosine of 0, which is 1, multiplied by 2, which is 2. These should be meters. Sorry, I didn't emphasize they were meters. And then for the vertical position, sine of 0 is 0, so 0 times 2 is just going to give me 0. So my vector r is going to have components 2, 0, and that's meters. So how I would plot this, let's say I'm making, I'll make this 1 and this is 2. So here's 1, 2, here's 1, and then here's 2 right there. So my vertical position, I guess I should say meters. I'm going to plot it at 2, 0, so it's going to be right here. So that's the position right there. Now let's do it for 1. So Rx when time equals 1 and Ry when time equals 1. So if I plug that in, I'm going to get 2 cosine of pi over 4. I plugged this into a calculator before. It ends up equaling 1.4 meters. And same with sine. When I plug in 1, I get sine of pi over 4 times 2 is also 1.4 meters. So this is 1.4 meters, 1.4 meters. So my r vector is going to be, my r vector at 1 is going to be 1.4, 1.4 meters. And so I would plot that at, let's see, here's 1.5. So 1.4 might be around here, and then I'll do that as well here. So 1.4, maybe it's going to be about right there. So there's the next position. You could draw out the r vector position, but I will say after 16 data points, it's going to get a little messy. Once you take the derivative, so it's going to make a pattern. It's going to make a pattern you're going to see. Once again, with these 16 data points, you can use Google Sheets, so you don't have to do that over and over again. Just let me know. I use Google Sheets. But please show me your derivative. So you're going to take the derivative of this, and you're going to get a velocity, velocity functions for each one of these. So one will be for x, one will be for y. I don't want to tell you what it is. That's for you to figure out. But once you get these velocity functions and you plot them, you're plotting them for, I forget exactly, it's 0. You're plotting for 0, 2, 3, and 4.5 seconds. Draw those velocity vectors as coming out of, so let's say this is not what your velocity vector is going to look like, but let's say the velocity vector pointed to the right like this at the 1 second mark. So that would be your direction of your velocity vector. Or let's say this one pointed like this. That would be the direction of your velocity vector. That's not going to be what it is going to be. So here's like, this is 1, this is 0. So point your velocity vectors and your acceleration vectors as pointing out of the object of where the object is. So yeah, So yeah, similar to, again, this diagram, right? The velocity vectors are being pointed out of where the object is, but they don't have the position vectors showing like where, you know, where the object is, because that's just going to clutter things. But for the, yeah, have the velocity vectors pointing in one direction, pointing in their direction coming out of the object, and the acceleration vectors pointing in some direction coming out of the object. Speaking of the direction of the acceleration vectors, this question number 13 should have been, what do you notice about the direction of the acceleration? Sorry about that, my bad. The acceleration vectors at those points. So, yep. Hopefully that helps. All right, and I'll see you guys. Bye.